Section 1: Electrochemistry and Batteries. Chem Talk. Oxidation reduction reactions and electrochemical cells. Electrochemical cell. An electrochemical cell is a cell or a battery that uses chemical reactions to generate electricity. When two metals of differing electron-releasing tendencies are connected, an electrical potential is created between the two metals. The electrical potential, or voltage, is measured in volts and represents the energy that drives electrons through the wire connecting the two metals. A 9-volt battery has a larger electrical potential than a 1.5-volt battery. Current describes the amount of flow of electric charge. Larger batteries can generate larger currents than smaller batteries. Some metals tend to lose electrons or become oxidized more readily than other metals. Examine the metal activity series shown on the next page. A metal that is higher in the activity series will give up or release electrons more readily than one that is lower. You can make use of these differing tendencies to convert chemical energy to electrical energy. As you may have found in the investigation, metals that are furthest apart in the activity series will produce the largest voltages. Metal activity series. A battery is a system that directly converts chemical energy to electrical energy. The Consumer Electronics Association claims that there are over $4.9 billion worth of batteries sold in the United States in 1 year. The typical batteries used in toys are more correctly called electrochemical cells. If you examine any commercial battery, you will see two terminals, one terminal marked positive, while the other is marked negative. These are typically located at the ends of the battery. Electrons which are negative flow from the negative terminal of the battery. If connected to the positive terminal, the electrons will flow toward the positive. Wires and a load provide the path for the electrons. The load may be a motor or a light or something else that runs on electricity. Before considering how your chemical batteries worked, look at a simpler system. Consider the following reactions. In certain situations, neutral zinc loses 2 electrons. When that happens, a zinc ion and 2 free electrons are formed. Since the zinc has lost 2 electrons, the charge on the zinc ion is positive 2. In certain situations, a copper ion tends to gain 2 electrons. When that happens, a neutral copper atom is formed. The copper ion had a charge of positive 2, so it needed 2 electrons to become electrically neutral. When the neutral zinc and the copper ion interact, as shown by these reactions, the neutral zinc supplies electrons to the copper ion. This flow of electrons is produced by the potential difference, voltage, and the result is a battery. The zinc reaction of losing electrons is called oxidation. The copper reaction of gaining electrons is reduction. Each of the two reactions are called half reactions. Loss of electrons equals oxidation occurs at the anode. There's the gain of electrons. Reduction occurs at the cathode. A mnemonic device to remind you of these two procedures is Leo the lion says GR, meaning lose electrons, oxidation, gain electrons, reduction. The pair of reactions occurring at the same time is called an oxidation-reduction, often called redox reaction. There's zinc, copper, zinc, copper. One of the characteristic properties of metals is that they tend to lose or give up electrons more easily compared to nonmetal atoms. When an atom has lost electrons, it has been oxidized. No atom or particle can be oxidized unless some other particle is simultaneously reduced. An atom is reduced when it gains electrons. In the investigation, the zinc metal and the copper ions were kept separated by using a porous barrier. This separation forces the electrons to flow through the wire and the load from the anode, zinc, to reach the cathode, copper. In this way, electricity is produced that can do useful work. The zinc anode is bathed in a solution, while the copper cathode sits in a solution in the porous cup. Because the nitrate ions do not participate in the reaction, they are referred to as spectator ions. Typically, they are not written into the equation. When the wire is connected, the zinc metal is oxidized to zinc ions, which dissolve into the solution. The copper ions are converted to neutral copper atoms that come out of the solution as copper metal. As the reaction takes place, the zinc half cell becomes positive and the copper half cell becomes negative. This would slow and eventually stop the reaction unless the two sides can become electrically neutral. The porous cup allows for the negative nitride ions to move from the copper half cell to the zinc half cell. This keeps both sides neutral and the reaction continues. Your car battery is a wet cell battery that functions similarly to the electrochemical cells that you created. However, most toy batteries are dry cell batteries. They operate on exactly the same principles as your electrochemical cells, but the electrolytic substances are in a paste form.